Hi everybody and welcome. Today we're going to be going through measuring the distance of line segments and also calculating the midpoint of line segments. So after watching this video, you should be able to look at a line on either a number line or a graph, be able to calculate its distance and calculate its midpoint. As always, we're going to start off with the application of what we're doing and an example of why it would be important to calculate a distance of a line would be something like this. So let's say my wife and I this fall, we want to go to Niagara Falls. She's never been, I've been a few times, so that's one of the things that we want to do. And if we're leaving from Delaware, which is on the map over here, we have to go all the way there. So if I draw a line straight from the Career Center to Niagara Falls, we'll see again, not a perfectly straight line, but if we were pretending that's about what it would be. And if you're looking at this right now and you're like, hey, Mr. Reardon, you can't drive through Lake Erie, well, maybe we're looking at flying, the shortest possible route. So if we're looking at the shortest possible route from one place to the other, we would need to know, how far that is. So if I'm flying in an airplane, the pilot needs to know the distance that we're going so that he can fill up the gas to the appropriate level. Because if not, maybe we will end up in Lake Erie, but maybe not by choice. The second thing that we'd probably look for is, maybe if we were driving, we'd want to know midpoint for a good stopping point. So if we bring the dogs with us, they need to go to the bathroom, or we need to fill up our car with gas, we don't want to stop multiple times. That would be another application of like what is directly in the middle. If you've ever done like a long road trip, for example, you probably don't want to be stopping a ton. You want to have the most efficient stops. That way you're not, spending extra hours and days on the road as opposed to getting there as quickly as possible. Another quick application of this, so basically when Google Maps is calculating how far you're traveling, how long it'll take, it is actually using a whole bunch of line segments. I know that it does look like curves. So for example, if we're like tracing our path through 71 through Cleveland up to 90, that is a series of curves. But if you look at a curve and you break it down, it's actually a series of a bunch of really, really, really small line segments like this that connect to make a curve. So really small line segments, and then they would connect like that to make a curve. So Google Maps is actually programmed using the formulas that we're going to use in class today to calculate distance. And if you're ever looking for a midpoint as well, a halfway point, that would be another example of a formula that would be programmed into the computer. So what we're doing today is real. There is a good application for it, and we're going to kind of get to the nitty-gritty behind a lot of the technology tools that you use, especially for travel. So to start off today, our first definition is distance. And our geometric definition of distance is the length of a segment defined between two endpoints. That's just a really fancy way of saying the measure for the distance between two endpoints. So if our starting point here is Delaware and our ending point is up in Niagara, those are the endpoints, and our distance formula is going to help us to be able to basically find the distance between those two things. So two different applications of this. We have 2 dimensions and 3 dimensions. So if you're looking at a number line, that would be an example of a 2-dimensional distance. If you look at a coordinate plane, 1-dimensional for a number line and 2-dimensional for a coordinate plane. So I'll be more clear with this. A number line just goes one direction, left or right. So this is 1D. 2 directions is we have our number line, but then we also extend it up and down as well. So that is our coordinate plane. So 2 different formulas for each of these. And I'm going to write them down up top here. That way we have them for later. So our 1-dimensional distance formula is the absolute value of x2 minus x1. And in this case, x2 is one endpoint, x1 is the other endpoint, and it's always positive. So I'll write a quick note. All right, 2-dimensional, this does get a little bit more tricky. It is a little bit of a bigger formula. It does basically apply the same concepts, except we have to do it twice because we're in 2 dimensions now. So we need to know the left-right distance and the up-down distance, put those together. So we're going to have x2 minus x1 all squared plus y2 minus y1 all squared, and you take the square root. Something that you might notice that's similar x2 minus x1. Again, those are both, so that's like one dimension. When we put both of the dimensions together, we have to basically be able to derive distance in both of those dimensions instead of one. So a little bit more complicated, but the concept does remain the same for this. So let's go through some examples before we go on. So let me make sure I'm here. On the left, we're gonna see one-dimensional examples because, again, we are on a number line. If we want to intuitively think about this, the distance is 1, 2, 3, so we know that our answer should be 3. If we use our formula, we'll see that if we label it x2 and x1, start off at -3, subtract -6, and take that absolute value. So the absolute value, and remember KCC, if you're not using the calculator, the absolute value of 3 is just 3. So again, intuitively and using the formula, both of these things work for us. Next, before you start, just like we did before, let's label. So we have x and y, and x2 and y2. So always, always, always label. And what I would say, it actually might be helpful as well, is actually drawing the formula before you start. That way you're just plugging in numbers, make your life a little bit easier. So x2, x1, y2, y1, and for both we subtract. So my x2 is right there, x1 is right there, y1 and y2 are both right there. So I can use that as a guide to make sure that I am filling in the correct numbers. All right, so x2 is 13, x1 is 10, y2 is -7, and y1 is -2. So a lot of negatives here. Again, be careful with keep, change, change, keep those signs correct. Double check with the calculator. Quick reminder, calculators only do one step for you. They are not solvers, they are individual step calculators. All right, so going through 3 squared plus, again, KCC gets us -5 squared. The square root of all of that is going to be 9 plus 25. Again, -5 times -5 is +25. Get the root of 36, or just 6. If you're thinking, why is that not plus or minus 6? Distance, again, is always positive. So our distance from A to B here, and I'll write this up top, the distance from A to B equals 6. And again, we represent distance with just A to B. We don't need the line on top because the measure is A to B without the line on top. So that's shorthand geometric writing for writing out the distance. All right, so hopefully that should help you use that same kind of formula, the setup for B and C, and also for examples 3 and 4. All right, one more skill today before we close out. We're gonna look at midpoints. And I think this one's a little bit more straightforward, especially calculating not a whole lot of square roots or things like that. So what is a midpoint first? It is the point that is halfway between the endpoints of a segment. So for example, if we're again going to take it back to our map, if we had Delaware and we had Niagara, halfway in between, we'd probably see something like maybe like Erie, Pennsylvania. And again, if I'm trying to plan out a stop, maybe that's the place where we would go. That's exactly halfway in between. A lot of other applications for midpoints. Again, pretty useful skill, being able to fairly cut something directly down the center and not have to guess exactly where that midpoint is, but to be able to know exactly where it is. So again, we can think about this in 2 and 1 dimensions. So if we're just looking on a number line, our formula would just be x2 this time plus x1, but we divide it by 2. So that's 1-dimensional number line. If we are 2 dimensions, it gets a little bit bigger, x1 plus x2 divided by 2, and y1 plus y2 over 2, and that all forms an ordered pair when you're done. So it'll be an xy ordered pair. Okay, so 1 dimension, 2 dimension, and we're going to see examples of both of those today. So let's go through and let's first see if we can find a good example of a 1-dimensional midpoint. So just quickly to fill in if you need to these notes here. So the coordinates of a midpoint of a segment whose endpoints of x1 and y1, x2 and y2. I'll let you fill this in because we actually just defined that. But next, the coordinates of j and k on a number line are -12 and +16. They want you to find the midpoint. So if you were to guess, I'd be like, oh, okay, somewhere in the middle. I don't know, maybe like 0-ish. But if we want to calculate this exactly, we have to see -12 as our x1, 16 as our x2, divide all that by 2, we'll get 4/2 equals 2. So I know that 2 is directly in the center, and I'm going to check and see if I believe it. So to get from 2 to 16, it takes me 14 steps. To get from -12 to 0 is 12 steps, and then 2 more gets me to 2. So actually 12 plus 2 will also get me 14 steps. So we're going to see directly in the center, equal walking on both sides, basically. 2 is our midpoint. Now, a slightly more challenging example. In 2 dimensions, they're giving us some ordered pairs here. Just like before, always start off with labeling. And then after you label, your life is a lot easier because you're just using the formula from before and plugging in. And again, with midpoints, we add. So let's just identify real quick. So we have x's, and we also have y's. All right, so let's write this in. Let's be careful about how we do this. So x1 is -1, x2 is 6, y1 is 2, y1 is 1. Okay, so now we can go through and calculate. So we would get 5/2 and then 3/2. Both improper fractions, they won't cleanly divide. So I'm okay with you leaving them as improper fractions. If you wanted to leave this as 2.5, 1.5, that's okay as well. But again, some quick examples. So if you're starting off that example number 4, again, start off with labeling, plug into your formula, go through and solve, and use that order. That's going to be really helpful to going through. Any questions, let me know. Be sure to submit that form, and looking forward to seeing everybody in class soon as well. Thanks for tuning in.